Okay, now we're going to move on to looking at data summarization. Let's pull this up. And so I think it's important to note too, if you do want additional practice, in that R for Data Science book by Hadley Wickham, which is linked in our homepage and also in that first slides. This might give you like a different perspective or additional reading you could do to sort of learn some of these concepts. And so as of now, we've kind of covered some of this initial explore section where there's data transformation. And so, for example, looking at filtering, arranging, selecting, mutating. Right now, we'll cover these group summaries. We've covered tables a bit, data import. Through the data cleaning lecture, we'll be covering tidy data. And so if you just sort of look through this introduction, explore, and want to read a little bit more, this is a useful resource. Again, there's also example questions that you can practice with. So for example, with filter, this has like a data set he reads in, this flights data set, and talks about filtering rows with example code, comparisons, pictures for logical operators, missing values. Then there are exercises, so like you can practice your logical test with like how many flights had an arrival delay of 2 or more hours and things like that to just get more comfortable using some of the syntax. Cool. And so after you've read in some data and done some filtering and subsetting, you maybe want to start looking at some basic summarizations of your data. And so some of the ones that are most commonly used are listed here. So if you just want to take the mean of one of your columns, you can use the mean function. There's a standard deviation function, median. There's a quantile function, which by default will give you sample quantiles of x, which is the minimum, the interquartile range, which is 25th, median, 75th percentile, and the maximum. Range will display the minimum and the maximum, and sum will take the sum of x. All of these have this na.rm, which is like, how do I deal with missing data, which will be discussed later. And so if you do have missing data, you would say na.rm equals true. So remove any missing data before calculating the means or sums or standard deviations. There's also some basic transformations, like the log function is base e, it's the natural log. Log2 is a log base 2 transform, which is popular in genomics. And there's also log 10 transform. There's square root, and then there's correspondingly exponential exp function to sort of undo a log transform. And so we can use the JHU cars data set that we've packaged up in the JHUR package to explore different ways of summarizing data. And so again, just as a reminder, the head command displays the first 6 by default rows of an object, and so we show that a lot. So if we read in this data set by loading the package, you'll see that this is just that empty cars data set where we move the row names to the car column name. And so we've used this in the previous lab. And so if you want to know the mean horsepower in this data set, you would say mean JHU underscore cars $ horsepower. That'll give you 146.6875. And so that gives you one number. If you use the quantile function of horsepower, it again gives you different quantiles, the minimum, the maximum, 25th, 75th, and median. So it can let you just quickly visualize sort of the distribution of your data. You can provide any custom quantile percentiles that you want to the function. Again, median of the weights. And so, yeah, if you wanted to say, like, hey, let's take the 60th percentile, you'd say probs equals 0.6. That says, hey, the 60th percentile is 3.44. And here you can actually collect multiple percentiles to do in sort of a vectorized way. And so, for example, I can say percentile JHU cars, make this bigger. HP, we can do like 0.1, 0.25, 0.67, 0.99. Sorry, quantile. And so it'll return each of them for you for whatever the actual value was. And there's some other functions we can cover that might make a longer vector of numbers, like you having to type each one. Another summarization that's popular is the t-test. We're going to cover this more in the statistics lecture, but the idea is if there's a function t.test, and so by default, if you just give it a vector or one column of your data set, for example, the weight of the cars, it spits out this this label for you where it says, hey, this is a one sample t-test. This is the data. This just tests whether those values are not equal to 0. It's a 31 degrees of freedom here, and the p-value is highly significant. And it gives you some information about the 95% confidence interval for that mean, which is 3.21. There's a useful function package called Broom, which tries to clean up some of this text-looking output and what becomes sort of this list output using the tidy function. Again, we'll cover this in a little bit more detail later, but the idea is you can get back out a tibble from some various statistical tests or summarizations, and then be able to use the $ sign to extract out the p-value or the statistic or the confidence interval low or high. However, it's important to note that many of these functions have additional inputs regarding missing data. And so again, the na.rm argument is just like, do I want to remove NAs, which are missing? So if I collect this vector of 1, 5, 7, NA, 4, 2, 8, etc. If I say, let's take the mean of this, even if there's any NAs at all, the mean of this vector is NA, because it doesn't know how to handle it. And so if you do have any missing values, if you say na.rm equals true, and so again, it's false by default, so it'll say, don't remove missing data, just return an NA. If you say na.rm equals true, it says, hey, now this is the mean, and so it'll basically remove this value, sum up the rest of the vector, and then count how many non-missing variables were there to divide by. And again, if you want to use quantile, you also have to say na.rm equals true, otherwise you'll get NAs for each of the percentiles. So that's sort of in a one vector, like one column of your data. If you just have like big matrices of a bunch of different numbers, there are these helper functions for matrices or data frames. Note that these only really work on all numeric data. They don't really work on categorical data. And so if I have this big matrix, I can say row means, which takes the mean of each row of X. Column means takes the mean of each column. There's also row sums and column sums. A useful function overall is a summary function, which tries to display quantile information for numeric variables or just sort of string information for categorical variables. And I'll show an example in a second. And if you do a lot of stuff with matrices, especially like big matrices, there's this matrix stats package that does a lot of more flexible, very fast operations on matrices or summarizations on matrices, like row FDs or column quantiles or things like that. Although we don't use a lot of matrices in this class. And so with these sort of basic summarizations, we can pop open the lab and start part 1. Again, it's back on the class website under Data Summarization Lab. So here we'll be using a new data set called bike lanes. And this is a data set of various bike lanes that Baltimore City has either created or has annotated. And so we have a version of this. You can download it here. It's also in the JHUR package as well as read on bike. Okay, so let's come back together here. And so part one had two questions. So how many bike lanes are currently in Baltimore? You can assume each observation or row is a different bike lane. And so the n row function is helpful here. It just tells you how many rows there are. We can run some of this. So 1631. You can also just use dim. It'll tell you how many rows and columns. It's sort of, again, an automated way without having to look at your environment. And if you like piping for whatever reason, this is a way of you can use piping, although it's not as maybe useful. You basically take bike and then pipe it to the n row function. I need to. So sometimes you'll see that error message. It's because you don't have dplyr loaded. And so again, they're all different ways of doing the same task. It's just the idea of like counting how many rows there are. So whatever one you feel most comfortable with, you're totally cool to use. So how many feet and then miles of bike lanes are there currently in Baltimore City? So that will involve using the sum function. We'll sum up the bike length to get the feet. We'll assume it's in feet, and then divide it by 5280 to get the miles. And so you can do this either way. If you want to just take the overall sum and divide it into miles, that works. Or you can divide each length into miles and then sum up the miles. Get the same answer. Do people have any questions on that? And everyone is able to get the bike data set into our studio and all that fun stuff. Cool. Okay. So now we're going to use a different data set. It's for tuberculosis incidence data. You can download it here if you want to follow along. However, you can also use the JHUR read TV data set to read this in directly without having to download anything. And so here they have column names corresponding to years. And so here we have the first column name is actually TB incidence something. We can look at what that is with the column names of, say, TB. And so this table contains, sorry, you probably can't see that. This table contains TB incidence, all forms per 100,000 population per year. And again, this is just the column names function. We're only looking at the first column name with the brackets, like you kind of see in the output of your R console. And so you'll see this sometimes when you read in data sets, they have these backtick things because there are spaces in the name. And base R, if you use like read.csv, kind of removes those spaces by just filling it in with like an underscore. But our reader is more flexible where it'll basically keep spaces, but then use these backticks. And so that can be kind of annoying because it makes these variables harder to call. And so, for example, if I have a data set like my empty cars data set, if I say like column names cars 1 equals my car, it has to be a Tibble, sorry. So if I have like Tibble, and I say, let's make the first name have like a weird space in it. Okay, it's hard to induce actually. Sorry. Okay, so like you can have these column names that have spaces. And so if you read something in and see this, it just makes it really hard to access. And so if you do see this and for whatever reason you want to use it, If you want to use the $ operator, if you just say my space car, it doesn't like that. It's like, hey, there's an unexpected symbol in this call. This is where these backticks come in. They just sort of tell R that like this is the entire string you should evaluate when pulling column names. And so you typically don't want to do this though because it makes additional typing. It's kind of annoying. Other things than just spaces sort of get preserved that are hard to type on a keyboard. Like maybe like units of different like biological measurements, like microliters or something has like the U micro. And so you typically want to get rid of this. And so, for example, in this TB data set, we want to get rid of like all this stuff like parentheses like don't really work as an R variable name. Commas don't really work as an R variable name, but you could call this whole thing with backticks. And so, for example, if I wanted to rename this with the dplyr rename function, I could take TB, type it to rename. The old column name was this huge backtick thing, and then I'm going to just say that as country. And so whatever column name that was turns into country. It's all fixed. It's now the column name of our country, 1990, 91, etc. And so one useful function in dplyr is summarize. This allows you to summarize data, as it's called. The format is new label equals some summary. If you don't set this new label name, there's a messy output of it. So for example, if I want to summarize the mean, in this case incidence, on each year, I would make an output saying mean underscore 2006 equals mean. And here I'm also using backticks because R doesn't like columns named with numbers, at least starting with numbers. It really needs like an alphabetical name. And so you also have to use backticks here. And for example, if you don't label things, and so if I label it, I get the mean of 2006, 135, mean of 2007. Instead of the median of 2007, I get 53. But if you just say, hey, let's just take the median in 2004, removing missing values, you get some label that's just some backtick thing saying like remove. And so if you don't give a name, you get this sort of really ugly output, especially when there's like spaces and backticks and things like that. And so we always recommend, like, if you're using summarize, you can even just say mean equals and like the function mean or whatever you're taking, but it gets much nicer output in a tibble format when you name things. And so then if you've named it and saved this to a new tibble, you can then call it with $signs or do anything you want, or access it like any other tibble column. And so this is maybe just one example of how we would use column means and row means, although again, like a lot of the time you wouldn't have all numeric data. So let's just like take all years before 2000. So here we'll like assume they all start with a 1. And so again, this is where this like helper functions come in from Tidyverse, where I can say select TB, anything that starts with 1. So I can get all of these years without having to type each one out itself. And so now column means of this new matrix is, you can see that in 1990 it was 105, in 1991 it was 107, 108, etc. And here you can like add this as a new column to your tibble or to your data set. And so if I wanted to say, hey, what was the average incidence before 2000, I could say, let's just take this row means and add it as a new column. And you can also do this with the mutate function as well. So you'll see that it becomes a new column, and so now I can see country, and then before 2000 average, it's now present in my data set. If you're doing this, it's important to note that like if I took column means, I couldn't append this because it has a different dimensionality, because like you need one value per row, and this would just have one value per column. And so instead of just summarize, there's an equivalent for summarize all. This has a slightly different syntax. It's data set, function, other function arguments. And so this is, again, a very similar output where I'll say summarize all. If I have this already existing averages, which again was only those years that start with a 1. I want to take this tibble, take the mean, and then other arguments involve na.rm equals true. So like if you hadn't done that na.rm equals true, you would just get all NAs because there's at least one missing value in each of these rows. And so that would also have affected, the summarize all call. And again, you'll get back to the table here with the same names that the columns originally called, but so they still have these backticks. Another just useful sort of way of like just looking at the distributions of your data are the summary function. And so summary on TV gives you quantile information as well as how many NAs there are for each of your columns. For like if you have 15 columns, it's fine to do this, but if you have like 1,000 columns, you're probably not going to want to run this and like have to look at each one of your outputs. But again, it's just a useful way of just looking at the distributions of each quantitative variable kind of quickly with, you get a lot of information out of looking at this. And it's especially useful to see how many NAs there are because then you can just see, hey, maybe I read my data wrong or maybe something got messed up in the parsing. I should go back and like see what happened. So if you wanted to do this in a second data set, we can read in the youth tobacco survey data, which we talked about yesterday in the data IO lecture. And again, here we'll just use the helper function for read_YTS. And then I'll read this in as this table that has year, location, etc. And so some of the other useful summaries involve looking at the unique elements. And so again, a lot of this summarization now is for strings and categorical variables. And so if I take the unique location descriptions and just look at the first 10 of them, you can see it goes to Arizona, Connecticut, Georgia. And this will be in the order that it appears in your data set originally. And so you can combine unique with length to tell you how many unique elements there are in your column or in your variable. And so here there's 50 unique location descriptions because I'm taking unique first, which reduces it to just unique observations. And then the length is just counting how many unique observations there are, or like how long that vector is. Another way of doing this is with the table function. And this will do a frequency table of all the unique elements in your column. And so if I now tabulate this location description, I can see that there are 378 for Alabama, 240 for Arizona, for Arkansas, etc. This sort of orders it in alphanumeric order of the category of the labels. And so I'm just looking at the first 5 output of this. And you can also take the length of this table to see how many unique elements there were as well. However, dplyr, you can use the count function to do this. And so this also is nice because it returns a tibble, not a table, which kind of has some weird ways of accessing its data. So I take youth tobacco survey and I pipe this to count. Again, I don't need to say YTS again. It gets streamed in from the pipe. And I want to count the location descriptions. You can now see that you get a 50 by 2 tibble. It just prints the first 10 rows, even though all of them are in this output. And you get a column that says the original column name and N, which tells you how many there were. And so this is one way of just sort of counting columns in your tibble. The count function also can take multiple columns, not just one. And so if I wanted to take the two-way table of location, description, and age, this is not as useful because there's only one age label. But the idea is you would get, if there are 2 age labels, say Alabama age group 1, the count, Alabama age group 2 would be the second row, and then the count, and so you get a much longer tibble coming out of it. And so you basically would get the combination of the number of unique pairs of these variables as the number of rows of your tibble. And so let's just filter to smoking status, measures for all genders in middle school, for encourage smoking status using filter, and then just the columns that represent the year, state, and percentage using select. And so again, if you want to do this with an intermediary variable without piping, you could say, hey, let's filter this. We say measurement description equals smoking status, gender equals overall, response equals current, and education equals middle school. And this will just come up with the subset of rows. Then we're just going to select columns year, location description, data value, and then data value unit. And so if we look at this, you'll see, hey, now there's many fewer. And I can just do this alongside you guys. So this will reduce to 222 rows now. And so now there's an additional benefit of dplyr, which is this idea of grouping. There's this function group by, which allows you to group the data set by some variable. And in this case, I'm going to run group by, where I group this data set by year. And so if I were to run this, let me just make sure. As you'll see that there are 10 entries from 1999, 27 from 2000. If I just say sub YTS equals group by sub YTS year, and I print this now, it'll say, hey, your table fill, and then there's a new column, a new row that says groups, year, and then it says 17. However, the rest of the table looks exactly the same. And so like it visually doesn't look any different except for this one additional line that says groups. But if you run a function like summarize, before when it wasn't grouped, you would have gotten one number, which would have been the mean data value. But now that it's grouped, it gives you one summary per group level or group category. And so now you'll get a 17 row by 2 column output, which has year as the first column, which is your grouping variable, and then my new variable called year underscore average as the new summarization. And so a typical workflow is like subset to some data, group it, run summarize, and that allows you to make these sort of summary tables on subsets of your data or by some variable, by some second categorical variable that you want to summarize across. And a more common way of doing this, I would say, is to use this with pipes, where you don't actually save the group tibble somewhere, where you basically just take your data set as a tibble, pipe that to group by, which produces a group tibble, and then that gets sent forward to summarize. And so, for example, I can make a summarize call with 2 different outputs. One is the average, which would be the mean of the data value. Then a second one would be the median of the data value. And now you'll see that I get out my 1 row per year, and then the new variables, which are year underscore average and year underscore median. This doesn't change my YTS underscore averages, or sorry, it doesn't change my sub YTS data at all. It doesn't add the grouping permanently to it. It just sort of lets you do this on the fly and saves out the output you can then write out to a CSV or some kind of figure for, or some kind of table for a paper or a report or something like that. And sometimes you want to ungroup the data. There's an ungroup function. Maybe you don't want to use that grouping variable, or maybe you don't want grouping variables to be returned. If I say ungroup of sub YTS, it now removes that row that says groups is year. And so actually, if you check class of sub YTS, now it says the class is a grouped DF or a tibble DF and a tibble DF and a tibble. If I were to remove the grouping, you'll see that sorry, I'll make this at the top. So now that I've removed the group label, now there's no more group DF attribute or class of that. So that's another way of checking to see if it's grouped or not. So say we wanted to do this in another way where we group by some year, and now.
I mean, yeah, it's a little bit. So I, the trial stuff that I tend to do. A lot of times you don't want to just do. So summarize and group by insanely powerful, right? This is the other thing I wanted to talk about with tibbles. Data frames and tibbles are almost identical, except we said they print a little different. They show you a little bit more information, but a large aspect of it that's different is that tibbles can have this attribute of grouping. Data frames can't. Right? They can't have this grouping thing on there. For this, So we've talked about summarize, but grouping data and summarize, right, condenses your data down to like usually some sort of singular value. Many times what you want to do, like maybe let's say you have 3 blood pressure measurements or something like that for each patient. You want to group the data by patient ID, in this case it's year, and then you want to take an average. So then you can say, you know, in this case, year average is the mean data value. So it's like, let's compare Alabama to the entire U.S. average at that year. But that's what we're doing here. So not only can you summarize a coupon, you can also use mean data, but the big difference is summarize before had like what, however many years, types of records, right?
17, yeah.
Here it keeps all the rows there, it just adds a new column with the summary measure. That summary measure is repeated over and over again for each year.
So 2000 always has 12.5, regardless of what state you're in. But it just allows you to quickly see, hey, like 11.4 is less than 12.5, 19.1 is more than 12.5.
So, yeah, sometimes we do min or something like that, where it's like you find the patient's minimum value, maximum value, stuff like that. From a public health perspective, that might be a little bit more attainable than some of these. But these two together are super powerful and like the last pieces of the puzzle for us, really.
Okay, and then I think the last thing before the lab is counting. And so standard statistics can be calculated, but there's other functions such as n parentheses, which is a function itself to count the number of observations. And so instead of using the count function, once you're in summarize, you would use the n function. And so this would say, hey, again, let's take this subset of the data, group it by year. So now there's 17 levels. Then I'm going to summarize and have 2 summaries, n, which is the number of observations, which is just using the n function, and then the mean, which is using the mean function. And I can just pipe it and look at the head. And so here it's basically saying, hey, in 1999, there were 10 observations and the mean was 14.6. So using n just allows you to sort of have an additional column information that might be useful to say like, hey, I have a mean, but how many observations like actually went into this mean? And so I think we'll basically end there. And Phil, we'll start tomorrow with the lab, part 3. Which picks up on some of this. And again, like you'll see that the pace of the class is kind of picking up a little bit. We're starting to build on itself. That's kind of standard every year. So again, I would just look at, if you want more practice, that R for Data Science book is helpful. Now we've seen group summaries. And so if this grouping thing is kind of confusing to you, you can check out this group summaries to learn more about group by with more examples. And maybe Hadley Wickham might explain it in a slightly different way that resonates more with you. It's always good to see things from multiple sources. And he has some plots that we'll cover more tomorrow or at the end of this data summarization. And so you can see how summary is sometimes used, or how summarize is sometimes used in grouped and ungrouped examples. Again, if you have questions, email us. We're very responsive. Enjoy your afternoon classes for those who are taking one. A lot. Dang, is there a lot?
How many slides are
there? There's a base R plot. It's only 40 really.
No, basic plots, not base R. We took all the base R.
The base R is in like the supplement.
Yeah, we don't.
I'm not covering. I know. It's just 40 slides.
Okay, that's not bad.
Yeah, I'm actually basically done. We just covered some of the basic plotting with ggplot. It actually won't be that long, to be honest. It'll probably be 30 more minutes of this.
Actually, don't use summarize with a Z anymore.
What do you use, S?
Yeah, because
what's the difference?
They're the same. It's
just, you just changed the syntax.
The HMISC package is a summarize function, so it's just less.
I see. You don't have to use the colons. Did you want to do data classes or data? Oh, let me end my.
Oh, when I disconnect mine automatically.